Can everyone see my paper? Hello?
Yeah.
Yes, I can see it.
Okay. So for the GPT, I was looking at the code that was provided and I was having a really hard time trying to actually convert it from Tinger to PyTorch. Looking specifically at the data set, I realized that's where the TensorFlow was what needed to be changed the most. So I wound up actually having to kind of just writing the code from scratch in all PyTorch. So this is what I did. This is for the data frame, just how to convert the information for the code. I mean for the how to convert the CSV for the code. This is just taking in the CSV file. This is reading it into a data frame. I use the 80% random sample. I make sure to drop all blank lines. Additionally, I should talk about my data set. I wound up using Alice in Wonderland. I just used the Gutenberg website and that's just the book I chose. Like I said, 80% was for the training and then the validation. The prompt I said Alice walked down a hall of, and then so with one epoch, this is what happened. Basic information here, nothing really super interesting. I wound up doing it a total of 5 times. I have the loss, the training loss, the validation loss, the time it took for each one. And then we can see the output. So some of the output information was a little weird. Like I got these weird spaces and a lot of symbols in here. And I think that's just because it's a really text, like conversation heavy book, Alice in Wonderland. So some of this just didn't look that amazing, but my favorite output, because I did the output 3 times, was the third one, which makes the most sense. And I can see somebody taking that and actually rewording it a little bit and working on it to actually get a legible paragraph out of it. So I was able to get some decent information. Any questions on that?
So this was which model did you use? GPT-2 already pre-trained, and then you fine-tuned it with Alice.
Correct.
Where do you fine-tune it in your code?
Do I have that? Give me 1 second. I have to share my actual code. I don't have it on here.
Yeah, go over your actual code.
Give me 1 moment. I'm just trying to find it, bring it up. The name of the file was just test because I was just testing the information while I was doing it. But if we look, so right here I actually have the Alice in Wonderland text, and then my code transfers into a CSV file. So it takes the text and just puts into like blocks. And then the actual tokenizing happens. For right here, I believe that's where it does the tokens. Yeah, so it should be, yeah, I believe it's right here. So this is where it tokenizes the thing. I don't know why it's called sample outputs though.
Okay.
Any other questions?
Can you scroll up a little?
Yeah.
Stop there. Scroll up a little. Stop there, stop there. What is B input ID? That's batch. Batch is enumerate from train. So that's where it's training. Like right there. Where you see outputs, model equal outputs. You know what
Yeah,
I mean? Okay.
yeah.
And then after that, outputs is calculate the loss function. All right. Okay. Do you guys have any questions for Joshua? Can you go to that text that you liked that it generated?
The CSV or the original
Well,
text?
the one that it generated.
Oh, I'm sorry. Okay, let me go back to my Word document. All right. There it goes. If you like, I can increase the size a little.
Yes, please. Yes. So Alice walked. No, not too. Okay. Alice walked down a hall of urns. Okay. And was listening to the rustling of her neighbor. And they were just beginning to move as the rabbit came around. I am at first a rabbit, and I'm a rabbit. And she did say, "How much do you want to eat?" But then Alice repeated in a whisper, "What is to eat to eat?" And all was lost until she was near the end of the table and found the rabbit holding her nose in the hole. At last, a long and a angry reply was heard. "Rabbit, you'll eat to eat, nothing to eat." And Alice repeated, "What would be to eat?" And the rabbit soon ran on by. Was this really generated by
Yeah, this is what was
GPT-2?
generated. So what like I said, this was the most interesting output, more so than these other two. I like this one the best.
It's hilarious.
And what I think may have been interesting what I did in my code was that I randomized the data frame. So it wasn't just reading the data frame like in order of the book. So I don't know if that actually did any difference, but I actually thought because again, I saw the other ones have weird artifacts, which I didn't like as much,
Yeah.
but this one is the best.
What is the prompt for this? What was the prompt?
Alice walked down like a hall or something. Yeah, walked down a hall of, it was a
But not a hall
random,
of urns. It said
yeah,
hall
right.
of urns. Okay. That's interesting. All right. It's actually very, very well, like grammatically. I mean, they're good.
Yeah.
But it's just astonishing how that is. This is what I had told you guys. It's like it yarn, it tells of some totally fake story, but well grammatically. All right, great. Do you guys have any other questions for Joshua?
All right, let me
Any
share my
questions? All right,
presentation.
Josh, do you want to do the other part of the project?
Yeah, let me just share my screen to the presentation.
Yep.
So can I make this, if I make this full screen?
So you're doing sequence classification of flash reading e-score.
I just made it full screen. Do you guys see the full screen version of it?
Yes.
Okay, cool.
Yep.
So yeah, so this is sequence classification of what is called the flash reading e-score. This is just basic information about sequence classification. We've talked about this during the class, so I'm pretty sure I don't have to go over this. Specifically, I'm looking at text classification, and it's going to take the data and assign a label to it. What I'm looking at is called the flash reading e-score. It's just a readability model that determines from a piece of text how easy it is and assign what a grade level of an individual should be able to read it. This chart, which is kind of helpful over to the right, it just kind of gives a range of saying what the score ranges for what grade. What's weird about this one is the higher the number, so I guess is easier to read, so the lower the grade. I would just assume it would be backwards, but yeah, so this is how they structure this one. So when I was doing my research, getting this project ready, one of the biggest hurdles that I encountered was actually finding a good data set for this, to do this, because not only did I want to find a lot of text that had this scoring system, I actually wanted to, that was mostly the issues, finding a lot of text that had this this scoring system. So I was able to find this thing called the clear corpus, which was actually really nice because it is about 5,000 passages. And not only did it have the flush reading one, it also had a total, I believe, 9 different models. So future use, you can use it for other things as well. Something also interesting about this specific corpus that I found, Kaggle, the website, actually recently just closed a competition where the top prize was like $10,000 for who can develop the best model for exactly what I'm doing right now.
Oh yeah.
Um, yeah, and interesting enough as well, a lot of people on there was doing transformers. So I
Mm-hmm.
saw people who use transformers. I saw people who wrote, machine learning from scratch. So it was really actually cool to look through.
Okay.
Um, so this is just more information about the data set, about where it came from. Like I said, it's about, actually, no, this isn't the right page. So this is just more information. This talks about the Kaggle competition. Um, and then this is pages that shows like the 40 different fields. Like I said, there was 9 total readability indexes, and I mean there was just a lot of information about the actual different, the book, the author, and all this other information. So for my project, I only really needed 2 of the columns, which was the excerpt, which was the loaded passage, and the flash reading ease score. So
Mm-hmm.
this code right here is just importing the information into a data frame, and then transferring that to just grab those 2 columns. Additionally, because of how the grading is done with decimals, um, each individual score needed to become a label. So by having all these additional decimals, and only having about, like I said, 5,000 um, 5,000 entries, it would have made it like 3,000 different labels. So what I did, and that just wouldn't equal out to like the amount of data I was looking at. So what I did was I chopped off all the decimals. I didn't round or anything. I just chopped it off by turning into an integer and then turning it back into a string. And that just gave me the raw number, and that reduced it, I believe, to like 80 something labels, which was much like better just for the predicting.
So you have 80 labels.
About 80 labels. I believe it's a little more. I believe in the future slide it showed the actual
Can you
label
can you go
number.
back to the slide where you showed like the rating and the grade level?
Yeah.
So I thought your labels would be this. I thought it would be you're at 5th grade, 6th grade, 7th grade, 8th and 9th, 10th. So this would have been just 7
No,
labels.
so what I'm
What are you predicting then?
expecting is a score number. So it's going to give me a raw output of like 67, about 29, and it's going to lie in between one of these
So
columns,
you
right?
you want a value between 0 and 100 basically.
Correct.
And you did 80 of them. So they're basically like 1.
I'm sorry, basically 1.
Well, I mean, if your value goes from 0 to 100 and you have 80 labels,
Mhm.
so it's like 1 point something, right? Each one, you made intervals of like 1 point something, it seems.
Yeah, correct. So this was
But that's
taking
almost like a regression. I get that you made labels, but when you have like that, it's literally almost a regression. Okay, I see. But yeah,
well,
continue.
okay.
Okay.
Um,
Why
so
not
the,
just do these 7 classes though? That's
I could have done the 7 classes, but when
Mhm.
you use the actual model to predict the passage, it gives you a decimal number of in between. It doesn't just say like this passage is at a 5th grade reading level. It gives you an 89 or a 70 something, right? So I was trying to keep close to the actual what the
Yeah.
readability model was predicting, which was a raw number, which is
Okay.
why I was assigning those raw numbers rather than just assigning the grade level.
Yeah, I see. Okay, keep going.
Um, this is just an example passage that I use to test. I'm in a research class right now, so I just grabbed this from my research class. I
Mm,
threw it in an online calculator, and
mhm.
it gave me the readability of this passage, which is 24.7, which
Okay,
again would be in that graduate level frame. So that's
okay,
just so when I'm checking the how accurate this model or the models are, I know what I should be looking for.
okay.
And then speaking of the models, like I said, I used a lot of different models to see which one would perform the best one. I started off with the code that you provided for the single sentence analysis,
Okay.
and then I was modifying it. And because that's a BERT fast tokenizer one, I made sure that I was looking for models that were specifically for a BERT. And
Mhm.
this is just the model search page from Hugging Face. So I
Yes.
just grabbed I grabbed 8 specific models from that page.
Okay.
Um, those 8 models can be as seen here,
Okay.
which is the BERT-based uncased one. Also used one from Google, used one from Princeton. Those two were really interesting. I was really excited to see what happened, and a couple of additional user-created ones. And surprisingly enough, I was able to get that code to work with one Rubert and one distilled Bert. So these are
Mhm.
just what was interesting about these last 2 options
Yep.
was because the code isn't made specifically for that model. I was wondering how it would predict on it.
Mhm.
So in order to wrap it, I essentially threw it all inside of a function, and I'm calling this thing called model choice, and I'm able to pass through different model choices, so I could just continuously run all through all the models at the same time, and I don't have to keep rerunning it. Same with the epoch. I decided to run it a total of 1, 3, and 5 to see how the accuracy would change in
Mhm.
accordance. So these are just for ease of use. Like I said, I decided to do it the 1, 3, 5 times. So I put that all in a double loop. I looped everything through all the models, through all the epochs. And a total runtime this took was about 4 hours. It was each model took about 30 minutes, somewhere a little faster, somewhere a little
This
slower.
on CPU?
A GPU.
Oh, you have a GPU. Okay.
Yeah. So
Good.
altogether, it took about, I want to say 4 hours for me to run this.
Mhm.
Um, so here are this is just an example of about how it looked during the running. It would just give me information about the number of examples are looking at, how many epochs are going through and
So
all
you
this other
have,
information.
remind me, what's the data set look like?
The actual I don't have a picture of the actual data set just because it was so large,
Yeah.
but the data set I had 2 columns, essentially just the excerpt from a passage and then the score that it was given. Once I'm done with the
Mm.
PowerPoint, I can actually just show you what the CSV file looks like.
Yeah, because you put it in the same format as that Turkish data set, I guess.
Correct.
Okay. Yeah.
Well, and it worked because I only really needed to know what this score was, what it would predict the score.
Mm.
Um,
But
so it
but you
worked
made
for
the
that.
score basically a label.
Correct. And I
Maybe.
want to see what the text would label the passage as. I mean, the model would label the passage as.
Mhm. Okay.
Um,
And how many texts that you have? Like how many individual passages with a label did you have for
for the
training,
testing,
for the fine tuning
I used about 80%, and it was 4,725, I believe,
passages? Okay.
total. And I believe I used the 80% training percentage. So whatever that equals out to.
Okay.
Uh, this is yeah, show this. This is the end results. I put in the table and I just highlighted some of the interesting things that I thought. So initially I said originally that my favorite ones to look at was the Google and the Princeton ones because I was wondering how they fine-tuned it. and my original score for that passage was a 24, and both of these got the closest score, which was 28. So I thought that was very interesting of the passage. A weird one that I thought should have done better, at least for the first epoch, was the deep set BERT based one, because it's still a BERT one, but it originally scored it in the 70s, same as the two non-BERT ones, so which was to be more expected.
When you say it did it in the 70s, do you mean that? So I'm confused as to, you have 80 labels. What do
Correct.
these labels look like? Like, are you saying literally like you'll give it a text and it'll say your label is 73?
Correct.
But a string 73. So it has no meaning of numbers. It's just, okay.
No, what the 73 is a number, right? So it looks at the passage and it can determine that passage. So that passage is already assigned a label 73 by the algorithm. It says a passage of this complexity is 73.
Yeah, but what I'm saying is, like in machine learning, right? We have classification and regression. Regression is like a linear regression where we have a function and it predicts a real valued number from minus infinity to plus infinity, or through some sigmoid that compresses it into like 0 to 1, right? But the way that we had laid this out is that it would predict labels. So a label is like Setosa, Virginica, Versicolor, and Iris. Or even in handwritten digits, it predicts 0, 1, 2, all the way to 9, but those are labels. They're not numbers. Now you took these scores, and what I'm trying to understand is if you represented them as strings, so when it says it predicted 73, it's literally predicting a string class that's 73. To you, it looks like a number, but to it, it's just one of 80 classes. Do you understand what I'm saying?
No, I understand what you're saying.
Yeah, so I'm trying to understand what you did there.
I just got a question real quick.
Yeah, go ahead.
So you didn't label these yourself with the numbers, right? The data set you had already had the numbers assigned.
Correct.
You just truncated them.
Correct.
So then they wouldn't be strings for the data set. They would be numbers, right?
Yeah.
Does that help you, Professor?
Yeah.
Because he's only converting them to a string after, I think.
No, I get what Professor Calix is saying, because it's the passage is just assigned to a label of 73, for example. But what I was thinking was, because of the fine-tuning process, it would be able to look at the complexity of a sentence, and it would be able to determine a more complex sentence had a lower label.
Right. No, lower label, you say, but so what here, the trick is to understand in your transformer, this transformer is specific to, you use transformers from Hugging Face, right?
Correct.
And you didn't really change the architecture, correct? You just
modified it a little bit, but pretty much, yeah.
Well, the final layer is really the key question, right? So we have a BERT model. But then, if you remember, like for instance, when we talked about the two objectives of masking or next sentence prediction, you remember that? So for this problem, you would need a BERT model where that CLS tag, the first input, right, that gets, that you have at the other end of the transformer, you have the output vector. That vector then would need to go to a fully connected layer and then to some kind of a regression output, right, that goes from 0 to 90. So that's the key question that I'm trying to understand. If you have a pre-trained model, I'm starting to suspect that the final layer of that was a regression layer, not a classification layer, because if it was a classification layer, that final layer would have been like a final vector where you have several neurons as classes, and then you pick the highest one. Do you understand, Josh?
I understand. And
so the question is, what we can probably do is look at your Hugging Face models that you go. If we go to the model card on Hugging Face, we can probably say, it'll describe there, oh, this model is for regression versus labels. You know what I mean?
Yeah. Let me share my code because
That's where you're like, I'm not saying anything is wrong. I'm just saying that's where I'm trying to understand if that's how it works.
oh, I get you. So you're saying that the actual model itself has the regression in it.
Yes, exactly.
Okay.
So in that case, if you put the values in that format in your CSV, that may be how you're supposed to do it, right? But the key question is, you grab these 8 models from Hugging Face. You did not modify the final layers, so it's possible that you just pick regression once. Like, how did you know to pick those 8, for instance? That's my question, for instance.
So when picking the different models, like I said, I knew I was dealing with a BERT tokenizer fast stuff. So I was definitely looking at BERT ones. And I was really just looking for what was interesting to me, to be honest.
Can we go to one of these on Hugging Face?
Yeah,
Like
give
the
me one
ones that you
moment.
think are the best?
Give me one moment.
Provide the most explanation, because that I think will answer a lot. No, it's good. I mean, if you can do regression with BERT, that's great. I can see how you do it. I mean, I'm not saying you can. That's the thing that I want you to like. That needs to be clear. That's pretty important.
I believe I did the 5, 12, 6. Give me 1 second. Just verifying which model I used. Oh, sorry. 4L4, this one. So this is the Google trained one I was using. 24. This is just a JSON file.
Just stay in the model card tab.
Oh, it doesn't really tell you too much more. I was going to
So
see.
this is the set of 24 BERT models. Reference. Well-read students learn better. Okay, English only. We have shown that the standard BERT recipe, including the smaller BERT models, are intended for environments. However, they are most effective in the context of knowledge distillation. Our goal is to enable research institutions. Scroll down. Note that BERT-based model is really. Go down.
Yeah, this one doesn't really tell you much.
Go to another one, maybe.
Let me see the other one.
But you get my point, right? That last layer is probably a regression layer.
Yeah, no, I understand now that you're. All right, this is the Princeton. Oh, this one doesn't have anything. Let me just open up another one. Let me just do the. Which one else performed? I was trying to look at one of them that performed well.
Yep.
Those are the 2 best performing ones. The next one, surprisingly, was the Woo Bird. Let me see what that is. Sorry, I'm trying to copy and paste stuff. Where is it? Okay, so let's see what this one says. This one was fine-tuned on a Russian task, which is sentiment classification. But it's interesting because it was in another language.
Go down a little.
That's the end of it.
Okay. Yeah, so I'm wondering if your values were treated as labels versus treating them as
I mean, originally I was thinking they would have been treated by labels, but I get what you're saying. And that could possibly be why some of them performed better than the others was
Let me see your data set. Let me see your data set.
the data set. Okay, give me 1 second.
Do you guys, and for the rest of you guys, do you understand my point?
Yeah, I think so.
Yeah, and where is the,
So these
This
are the
is
only
the-
two columns that I used.
so you use, okay, so you were giving it, and then what did you say about the decimal points? You confused me. You
I
said
just
you just got-
truncated them. Yeah, I just get rid of the decimals just for it
So
wouldn't be as many labels.
114.03 just became 114. That's basically what you
Correct.
said. And then, yeah, and then you made all of these. And you ended up with 80 of them. I thought they went from 0 to 100, but that's a 114.
Yeah, that's what it looks like. I actually didn't look at the data. I just knew the range is supposed to be between 0 and 100. So I guess there's some outliers.
And it ended up being at 80 of these.
Just about. So if let me see if I have
So what I would argue, yeah, go show that. Yeah,
yeah, I'm trying to see if I have the actual number somewhere.
Yeah, so stay the ID2 label. That's actually very insightful. Go back to that. Yeah, so ID to label, right? So you literally, that tells me that you 68, 59, 44, you treated those as labels.
Yeah.
And not regression value, which then it would make sense that it works with sentiment classification, because sentiment classification is text and pos negative, or like the Turkish data set, right? That text with like 7 labels. So that's my issue with this. I'm not saying it's wrong. It's actually an interesting result. I'm curious to see how it did, but usually this is a regression problem, and you would want to predict numbers, because the problem is here. Let's say you have 81, and no, let's say you have 68 to 79, right? And your model here can only predict 68 or 79, but it can't predict 69.
Correct.
If the label does not exist. But in a regression problem, it could predict 69 because it's predicting a value. But here, these are your labels. So it's hard, it can only predict one of these. And it's like a regression approach would probably be better. But yeah, I think I understand now. So go ahead, keep going.
Yeah, I mean, well, I was almost done. No, but I understand what you're saying, and it is interest. So the last thing I had was just my recommendation.
So what I would say is, if you wanted to do this as a regression, the key is to look for a Hugging Face model that the last layer outputs regression.
Okay.
In this case, I think you grab models that were similar to the ones we did in class, that grab labels like sentiment analysis or the Turkish data set. But those usually only have like 7 labels at most, or MNIST has 10. But when you tell me that you have 80, right, and the 80 represent values between 0 and 100, I would almost suggest that a regression would be better if you can find one in Hugging Face.
No, honestly, I really do think you're absolutely correct. But I mean, as you explained, that makes a lot more sense.
Okay, great. All right, so what were your results then? Let's see the performance.
Yeah, so the results, I believe I showed them, and I was just talking about the results. These are what the different models labeled my text as. And I was talking about how the Google and the Princeton had the closest, which were the 28s, and then the highest ones I was talking about. And those were, and respectively, it was 1 epoch versus 5 epochs. So that makes sense.
So yeah, so maybe this is that it picked up that when they were very well written, it was always this label, which by chance, but it makes sense. It was always 28 because there were a lot of samples that were 28 and they were good. So I see that. I mean, it's possible. It's certainly possible that it's not incorrect. But yeah, okay, all right, yeah, keep going.
All right. And then finally, I just had some additional recommendations if I was to continue doing this. I
Yes.
mean, now that we've talked about it, doing the regression model would make more sense.
Yep.
I was also saying running more epochs, testing additional passages to see how consistent the results were. And the reason why the next one was increasing the data set so I can have more labels so I can encompass all the labels,
Yep.
which is the way that I was originally approaching it. And then also testing different readability models. I was saying just to see how accurate the model would be for different readability models. And then testing with other things besides BERT.
Yeah. Yeah. Roberta.
Yeah. GPT. And then also saw a whole bunch of other stuff that we just haven't been discussing in Hugging Face.
Okay.
So that was it for me.
That's it for you?
Yeah.
Okay, good. Do you have any questions for Joshua?
No.
No questions. All right, so there are, in fact, apparently BERT regression models. So you can look for them. Yeah. So, yeah, so here we go. So let me show you Joshua. So BERT regression. All right, I'm gonna share my screen. Can you see it?
It just appeared.
Yeah, so fine-tuning BERT for a regression task. So you want to predict a property's list price, right? So I've always used, I think, in the classes, housing prices, right? So I usually do that for regression. You can see here, the idea is, and it predicts, I guess, some price there. And if you look, there's a graph here. And this is what I was talking about, that see that you use the traditional BERT layer, but then the final layer that comes out, so the CLS input, this is the embedding context, and that's got to be a regression layer which will predict real valued numbers, let's say between 0 and 100 versus actual labels as you're currently doing it.
So in this instance, you wouldn't have to feed the model labels.
Well, you feed it numbers, right? So you'll feed it from 0 to 100, assuming a range of 100. Okay. So, but it'll treat them as numbers. And as I said, the issue is with your case, if you have a label 65 and then 69, it'll never predict 67 because that label does not exist. But in regression, it will, right? Because it's predicting, it's tying not to IDs that go to labels, but the actual numbers that it can predict.
Oh, that makes sense.
So you can take a look at this and how they do it for more information, but I think that, I mean, it is possible. Kind of makes sense. Okay, all right, great. Guys, do you have any questions for Joshua? Nope. All right, great job, Joshua. Thank you very much.
Thanks.
All right, so who would like to go next?
I can go next.
All right, Kyle, so go ahead, please.
Okay, I'm going to start with GPT-2. Okay, so just to give some context, this was the normal GPT tensor code that we were given. I just increased the output to 600 just so I could compare what mine generated versus what the original TensorFlow one generated. So it's not very clear. This one I think only trains on 1,000 samples from the data set they create. But you'll notice there's a lot of like repeated commas for some reason.
Yes.
So I also did I can't think of the name, Alice in Wonderland, but I did another example as well, so it won't be a complete repetition. How do I hide this? Trying to switch tabs, sorry. Okay. So for my output for Alice in Wonderland, I used, well, for both of the ones I will show, I used the same beginning texts. So the cat jumped over the moon, the teacher ran around the school, and then this is the Weston from the example. So in mine is similar to the tensor version where like a lot of the words get repeated. I'm not really sure why. I've tried like different learning rates, different number of epochs, different batch sizes, which I don't think would change anything, but I tried that as well, and it always had the same problem. So I'm not exactly sure why.
Okay.
So this is the Alice in Wonderland version. And then I will show the other one, which was from a book called Sense. It's also by Austin, which is the Austin Emma is the same person. So this one also has the same problem, although this one repeats a lot more. You'll notice, especially in this example.
So can we give it something like in real time or not?
Yes. Let me go. Actually, maybe not. I can try really quick. It won't take very long with the Alice in Wonderland version. So this is just all of the code we were given before. I don't think I had to change anything except for which transformers I was using for PyTorch. So I'm just gonna run these real quick. This is a function I found that just splits the text into sentences because like Josh said, the code they gave us does not really work well with PyTorch. They kind of just encode everything at once and then split it later. And when I tried to encode that with PyTorch, it never came out correctly. I couldn't get the balance to work. So I just redid it. And this is like an example of how I split the text.
So you just rewrote it from scratch?
Not all of it. All I did was change how I encoded the text. So they get the text here, and then for like this example, rather than splitting it by sentence, they would just encode the whole thing. So that's the only thing I really had to change, aside from like the PyTorch training.
Okay.
So I'm not sure how long this will take. I don't think it'll take more than a couple minutes. So I can like move forward, and then we can come back later.
Yeah.
Let me just see how long. And I noticed, wait, this is the wrong one. Sorry about that. This is the one that should go faster. So I will show, I guess I can start with my PowerPoint while this runs.
Sure.
So for my project, let me swap the screen. Okay. Do you guys still see the full screen, or is it on the other one?
Not the full screen. We see the question and answering with.
I guess I'll just use the small versions. Should be fine. So I did question and answering with a fine-tuned BERT. So in order to do this, I had to look up like what formats data sets for question and answering were used. And then I remembered you mentioned squad in class. So I looked at that one. And this is an excerpt from the Hugging Face squad data set. And I will explain it a little better here. So this was made by Stanford. It consists of questions posed by crowd workers. There's over 100,000 question answer pairs from over 500 Wikipedia articles. It has 5 fields: ID, title, context, which is only up to 384 tokens. And then context would be like the passage. Then it has questions, and then it has answers. So like I mentioned, context is the entire body of text where the answers are found. And then the answer is, I can show it better here. It's the text as well as where the answer starts. So for each like entry, you would have the entire context. Then you would have a question, which would be like this. And then you would have the answers as well as answer start. So I decided to also do Wikipedia, but I wanted to make my own data set. So I used the Hugging Face load dataset function. And they have like every couple months, I guess they generate like total data sets of Wikipedia in different languages. And they clean it somewhat. It's like a lot better than if I was manually cleaning it, but there's still some stuff they miss. So I decided to create a data set of the 50 articles for each US state. And then when I made my data set, I encoded and then decoded them to all be 4,096 tokens in length. And I'll explain why I chose that number later. So then I looked up different ways to like actually create like question and answering data sets, because it's not super intuitive. So there's this tool called the Haystack Annotation Tool by DeepSet. And it's an open source framework for building search systems. So you, well, the nice thing about this before I go forward is that you can export, like when you create a question and answer, you can export it in squad format. So that makes training a lot easier.
Oh, that's nice.
Yeah. So I manually annotated.
Where'd you get this Haystack from? Where is it?
It's just a website. I can show it. I'll demo it after this.
Yeah, please.
This is just a screenshot of basically what it looks like. So I took my 50 states and I uploaded it, and then it lets you, you basically just select text, and then you would type what the question is, and then the selected text is the answer. So for example, which region would be the Appalachian region, is a what, it's a state, and then which part of the United States, Southern United States. So I did 6 questions per 30 articles, just 30 of my random 50 states. And that took a long time to do. It took me like an hour. So then I realized that that probably wasn't going to work, but I was still interested in fine tuning just to see if it would be worthwhile.
Yeah.
So I fine tuned a Distilbert for question and answering.
Yep.
And I also fine tuned a version with Squad. And you can see the difference between my data set and the Squad data set. So I have 25 train and 5 validate. And then Squad has 86,000 train and 20K validate.
Yeah.
And to nobody's surprise, my accuracy was not very good. Yeah, so from here, I kind of decided I was just going to implement fine-tune models that were fine-tuned by people with more time and resources than I had, because I was going to build a question and answering system. So after I fine-tuned, I built this question answering system, which is just a generic, like you provide it a CSV file of like a title of a Wikipedia article and then the Wikipedia article, and then it will drop down it'll populate a drop down list. And then when you select that, you can use that text for question and answering. So this is just an example. If you would select California, this just displays a quick summary, just so you know what text is in the option you chose.
Yes.
So now, once you pick a like a choice in your CSV file, you'll be asked to enter a question about that text. So this is shortened because I couldn't fit the whole thing, but this is a 512 token length article for California from Wikipedia. So then you ask it what is the capital, and it gives you Sacramento. So this is just one example.
Yes.
So when I used the model I made for this question answering system, it does not perform well at all. You can notice in this example, I used Delaware, and then I asked which region is Delaware in. It does manage to pick up the Mid-Atlantic region part, but it also doesn't stop. It just continues.
Yeah.
And a lot of the times it will just say unable to give you an answer because that's like, if you can't find the answer, that's what it'll give you. So it very rarely works. And that's just because I didn't have a giant data set to test it off of.
Yeah.
So then I switched to the squad fine trained model. This is the same Delaware article. And then this one picks up the mid-Atlantic region much cleaner. And then I asked it another question, who was the ruling governor? And then the governor you can notice is right here, Thomas West, 3rd Baron de la Warr. And then it provides that answer as well. So now my question answering system is generic enough that I can provide any sort of like Wikipedia article as long as it's title and then the text of the article. And it also allows for easy swapping of models. So I noticed that, or I was curious if I could get past the 512 token limit of BERT models. So I researched like different ways to do it. And a lot of people were just like, you should either truncate like the last past the 512. I believe there's papers that say taking the 512 from the middle is like the best way to approach this. But then I also found that there's this transformer called the long former transformer. And it's based on Roberta. So you can see this is a section of the abstract. Transformer-based models are unable to process long sequences due to their self-attention operation, which scales quadratically.
Yeah.
And then they create one which scales linearly.
Okay.
So this allows them to do a lot more tokens.
Yeah.
So from there, I found a long former model that was trained with the Trivia QA dataset, which is produced by the University of Washington.
Okay.
And this one has 95 like question answer pairs, and then 6 pairs per question on average. So that comes up to around 650 question answer evidence triples. And that's from their description. It's kind of confusing.
Okay.
And then this is the model. So then I also provide a version of my like system that uses the long former model. So that is shown here. Once again, this is cut off. I will show like a full demo to show you how long it is because it's like very, very long. I only use up to 2048 tokens. I can do 4096. It just takes a very long time to get an answer when you ask a question, but 2048 isn't too long. So, and then this one works very well as well. There's like a couple times I've asked questions that it wasn't able to find where the BERT model, which is smaller, was. So I don't think it's like as good, but it is still very good. From like most of the questions you'll get answers for. And unfortunately, I didn't like pay attention to the incorrect answer, so I don't have an example of that.
Okay.
So in conclusion, I learned that fine-tuning a question and answer model requires a lot of data that is like very well created. And then I learned that manually annotating such data set is very time consuming. So it's best to use open source data sets when you can. I also learned that long former transformers can bypass the 512 token limit of traditional BERT models. And then just overall my question answering system, you can implement or you can switch models pretty easily, as well as creating your own data sets as long as you have title and text columns. So I will now show an example. So this one, I will just quickly explain how I got the data set. So you're able to just load the data set from Hugging Face really easily. I used the pre-trained tokenizer for the long former that I used to tokenize the article text.
Yeah.
And then that way it saves a lot of space for just like the file size because I'm truncating whatever's past 4096 tokens in the articles. I just very easily just use if statements to determine if the article name is one of the states. And then I print it to a CSV. So this is just how it looks. And then this is like in data frame format. So now from here, this is where I use the haystack tool.
Okay.
So quickly I'll show if you want to export like a CSV file, you just have to change your column names to document text and document identifier. So For me, document identifier was the title of the article, and the document text was the text. So once you upload those, you can, it's a little slow. So you'll get a list of all your documents. And then when you go inside a document, and I guess this also works like you can have multiple people do this. So you, for example, I could show labels of all users if more users were a part of my like data set, but they're not. So you would just select, for example, if I wanted to make a new question. So admitted to the union on June 20th. So I would select June 20th, 1863. And I would say when is, or when was, what state is this? I didn't check. West Virginia. So I would do, when was West Virginia added to the union? And then it will show the other answers I have as well. So then this answer is linked to this question.
Mhm.
So then you can export it and it will provide you with, let me show this real quick. This is a JSON file. This is like the squad format. So this provides a little more extra fields than squad does, but it has the ones that squad cares about for the answers, which is the text,
Yeah.
and then the answers start,
Mhm.
as well as the question. And then there should be, and this is the context. So this would be the whole article. So now we go back. So I will show, this is the BERT version of my like tool. It is in Jupyter Notebook. So you run this first section, or well, I guess I can kind of briefly explain just how it's set up. So these are your imports. This is where you would change your model and tokenizer. This is a question and answer function, which basically you just provide it like the text as well as the, and it'll give you the answer. But for me, I'm getting that text from the CSV file. So I would populate this dropdown with the text from the CSV file. So for example, if I wanted Alaska, this is just what the Alaska section looks like, the first 1,000 characters.
Mhm.
So let's say I wanted to pick Georgia. I would pick Georgia and then I would run this section. And then it gives you, this is the entire 512 tokens for the Georgia article. And then you would ask it questions. So let's see. We do what region? And the Caucasus region of Eurasia. So it gets this right. And then you can answer or ask it more questions if you wanted.
So I have a question for you. This system only works where you give it a paragraph with text and it just, given a question, it's going to try to highlight the passage there, right? It doesn't give you an actual answer. It's more like give it a question, find the answer in the text.
I'm not exactly sure. So these are fine trained on question answering data sets.
Yeah.
So for example, this one was trained on squad.
But can you give it, what I mean is when you run this as an inference, can you give it a question and it just gives you a generic answer? Or is it always that you need to provide the question and the answer, and given the question, it'll highlight an area in the text to show the answer?
So do you mean, do I always have to give it like this input?
Yeah, yeah.
I believe so, yes.
Okay, yeah. So yeah, no, I believe it's correct. So that's how it works. So it's not like you can, it's not Google where you can go and ask something and you get pages, right? Instead, it's more like you give it this passage and then ask a question about this passage and it's going to highlight it.
Yeah.
That's how it works, even in inference mode. Not even training, but inference, right?
Mhm.
Okay, yeah, keep going.
And then real quick, I will show you the long former version, which is essentially the same thing, just a different model. So this one is fine trained on Trivia QA. And then I will run this. So this is a different data set. It was just 10 random articles. just to show that it can be easily switched. So we'll just do Star Wars. And then when we run this, this is 2048 tokens, which is much, much bigger. But I was just curious if I could get past the 512 tokens, which you can with long former. So this runs the same way. It just takes a little longer to get an answer.
Okay.
So let's see if I can find a good question real quick. I guess we can try, what is the Guinness World Records title? Okay, so this one does not pick the right answer because the correct answer would be most successful film merchandising franchise. But
Okay.
instead it guesses Star Wars. So that's pretty much everything for my Q&A project.
Yep. Okay.
So I can go back to the Alice.
Yes,
Should
please.
be finished by now. Okay, so yep, this is for this one I do 5 epics. Here's the loss as well as the total time. So now we can do the model. We can generate. So do you have an example sentence you want to try?
So I can give you a sentence?
Yeah.
Yeah, let's see. The pilot flew the plane into the mountain or to the mountain. What does it do?
It's going, so here's.
Oh, there we go.
Yeah.
The pilot flew the plane to the mountain. The, and the.
Yeah, this is like the repetition I'm talking about.
And two of the it, that she, the she of and she, and it talks about Alice.
It seems to get like better the more it goes. I'm not really sure why. Because
Oh,
like
yeah?
starting around here.
Bear the other, the simpleton of voices, snorting, disappointment, him, egg the cover, secret, his shilling going venture. Okay, yeah, so it's pretty hard to read here.
Yeah, I guess it could be. I'm not exactly sure like how clean.
Yep.
My sentence splitter sets it up. Every time I've like just checked random, like parts of it, they all seem correct.
Yep.
So, but it's possible it's like 8,000 different sentences, so there might be some mistakes.
Okay, no, it's fine. That's good. All right. I just don't see any connection between like the pilot flew the plane to the mountain and the rest of the text.
Well, the rest should be.
It's more like Emma afterwards.
Well, this would be Alice. So you have like
Or
Alice.
Alice, yeah, Alice. Yeah.
And you have like Cheshire here.
Yeah, exactly. I saw that. So it's just more talking about like it started and then the it didn't know what to say, and then I'm just gonna talk about Alice.
Yeah, I guess.
Yeah. All right, good. Yeah, great. So you presented GPT-2 and you also presented the question and answering example. Do you guys have any questions for Kyle?
I don't.
No questions.
No.
No questions, but the haystack thing seemed pretty cool.
Yeah, I was really happy I found it. I just wish there was like a different way, I guess.
But you didn't really, your annotated data was not really doing well, right? So you ended up just using someone else's, I think.
Yeah, well, I guess if I had like infinite time, I could do like a manually annotated one that would probably be better.
So haystack was just something that you could use if you had the time, but you really had to use another data set.
Yeah, because like I guess you might be able to create like a tool using somebody else's fine-tuned model to make a
Mhm.
data set faster.
Okay.
I thought about that like this morning,
Okay.
because basically you just like ask it questions and it would give you an answer, and then you would just send that to like some file, and then you
Mhm.
could use that to train, but then there's like the chance it's wrong. So
Yeah, okay. All right, that makes sense. Yeah, great job, Kyle. So very interesting. All right, who would like to go next?
I can go.
All right, go ahead, please, Jeremy.
Let me see here. So I will share, do the GPT thing first. Okay, can you guys see my screen?
Yes.
yes.
Okay, so I don't actually have the code for the GPT on my desktop. It's actually on my laptop, which I
Mhm.
can't really join Zoom on because Zoom is fighting with Ubuntu really bad. So all I have is the lab document I made for it.
Okay.
But basically, this is the part of the GPT homework where I fine tune the model.
Yeah.
So I pull in the data, which has been put into a PyTorch data loader.
Mhm.
I generate some outputs, and then in this section of condensed code, I have it actually output. It runs through 800 batches, and every 100 batches, it just like generates a sample of kind of like what it would generate at that point.
Yep.
And then it iterates through that. And then it has a separate second step with just validation. This part doesn't actually take very long usually to run.
Mhm.
On my laptop, it was taking, I don't know, about 10 minutes to go through the whole thing. So I ended up using the Emma Watson text that you had used in your example first to see what it would do. And then I was curious if I changed the text that was fine tuned with, what I would get for results.
Mhm.
Here's the function that generated some sequences. So it would generate 3 of them. I took a screenshot of the example. It's really hard to read. So instead, I just copied it out and pasted it into the Word document.
Mhm.
The first one it generated is honestly pretty garbage, similar to like kind of what Kyle had going on. Like you get a lot of he of and to the of and
Mhm.
like it just was pretty garbage on this, honestly,
Yeah.
for most of the Austin Emma.
Yes.
When I used Walden, I got one that was really bad. Like I have no idea what it tried to do there.
Mhm.
But the third example, I honestly thought was compared to everything else pretty good. We had
Mhm.
Watson was very good, if not good to himself. Some of our own writers refer to these of our predecessors, and they give to them the proof that they will live. He who is still better than himself, if he lives in such a state of life as it can last, and it just keeps going mostly coherently through the whole thing.
Yeah. Yeah.
I don't really know why it generated. Like it started pretty good for this first one, but then it got bad.
When you
Like
guys
really
do
bad.
1, 2, 3, is it just 3 instances, or is it that
Yeah,
one
yeah.
is
So it's
after certain
it's
iterations?
so
Are they
this is just
correlated to iterations? I guess is my question.
no. So this is after the model has been trained. It's
Oh, yeah?
this section. I can't really highlight it because it's just a screenshot, but it returns 3 generated sequences.
Okay.
But it's like 3 separate samples of what it would generate.
Yeah.
I also had an interesting problem where at first I didn't have this min length parameter, and I would the first time I would run it, I would get longer sentences like this, but then every other time I would try to run it, I would only get something about that long.
Yep.
And I added this min length, and then the first time I ran it again, it gave me a long sentence, but then still it would even then still sometimes rerunning it, I would just get short sentences. Sometimes it would only even return just the prompt, which in all cases was just Watson was very good. So I don't know what was causing that. I probably spent like 2 days trying to figure out why it was doing that and never really came to a conclusion. I ended up tinkering with it to the point that the algorithm ended up taking like 40 minutes to run. And it
What did you change to get those shorter sentences?
to get rid of them at first, I added this min length parameter. So there's a few different ways that the model can like generate. One of them was based on what you had in your code, which was like a beam path thing. This I forget what the difference is, how this one worked. I tried that one, and that one just like failed to generate every time. It would just like it would crash and hang up. I don't really know why. So I did some Googling and found an example of how to use GPT-2 in for PyTorch instead of TensorFlow. And they used this way of generating sentences. Their max length had actually been shorter at only like 50 or something, which I thought was, I don't know, a little short. So I tried increasing the max length, but I couldn't get it to do anything. I tried playing with like all of these parameters, and I really, other than the adding this min length, I couldn't get it to even somewhat consistently generate longer sentences.
Right.
Any questions about the GPT-2 homework or?
No. You can't run live right now, correct? You said.
Yeah, no, I can't, because it's on my laptop and I can't share the screen from there.
All right. So the question I have is, what model is it? Like, what base model is GPT-2? And then
it uses GPT-2, and it uses instead of the BPE tokenizer that you use, this uses GPT-2 tokenizer fast.
Okay. And then the other question is, you guys fine tune it just on that story, Emma, basically.
Yeah, the first time I ran it, I set a parameter. I don't think I actually have a screenshot of it. But this file name parameter, I downloaded another one. I downloaded Walden, and then the second time I ran it through with Walden just to see how with the same prompt, how it would change the like the generated text given a different like fine tuning body of text.
Yes.
And it was quite different, but in both cases, like I did get a lot of garbage out of it, what it generated.
Okay. All right, I understand. And you never tried like several stories. You just try. You always.
No, I did. I didn't load more than
or...
one. Yeah, I just loaded one whole book every time.
Okay. All right, that sounds good. Do you guys have any questions for Jeremy on GPT?
No questions.
All right, great job. So, do you want to start the other your other project?
Yeah. So, I was interested in seeing if I could do some unsupervised learning to cluster cluster movies into like have it cluster them based on genre, just given a plot summary. And I ended up finding a pretty good data set of 42,000 plot summaries that somebody had taken the effort to pull from Wikipedia from the beginning of Wikipedia until 2012. And it ended up being a little north of 42,000 plot summaries that they pulled. So my first task I had to do is like try to condense down for training purposes genres, because they're, some of them they might list 20, other ones they'd list one. A few of the data points I had to throw away because they didn't actually have a genre even listed, which was of course not helpful. So I ended up deciding that I would condense all of the genres down to just the first one listed, under the assumption that that would be like their biggest influence for when they came up with the movie, that like we want this to primarily be this kind of movie, and that they would list that first. Whether or not that's true or not, of course, who knows, but that's the assumption I made in order to get through it.
Sure.
And then I took the data set, because they had the data set broken up into just like the Wikipedia I guess identifier number, so that I guess you could take this and go find the original article. And then they had one file that had a whole bunch of metadata, which included like genre and producers and all that kind of stuff. The only thing I cared about was the genre, and then the other one had the plots.
Yeah.
So I combined those, and then just, of course, I didn't need the Wikipedia number, but I just used this to merge the two CSV files. And if you look through the sample of the data, there's like clearly some stuff like this plot tag that hadn't fully gotten cleaned out. And I did some work to try and clean some of this out, but ended up coming to the conclusion that it was going to take a lot of work, almost going line by line, to clean a lot of it out.
Yeah.
And I think it's just leftovers of pulling the markdown from Wikipedia where it's just like broken. So I ended up not trying to clean all of it out of there because it was just going to take way too much time to try and clean it. Time I didn't really have past what already automated stuff I had done. So then I needed to find a model, and I looked for like some examples of what people had done. And I found a example where somebody took Amazon reviews and tried to cluster them based on what like category of product they had been. And I figured that the model they used seemed to kind of match very generally what I was trying to do. And the model that they had chosen was the paraphrased distilled Roberta. The example that I had found used base V1. That didn't seem to exist anymore. It had been updated. So I used base V2. And then I fine-tuned the model over a course of 10 epochs. And I ran that on my GPU. It took, I don't know, like 5 hours. I ended up starting it overnight and just let it go overnight and woke up hoping that it would get through everything. And at first I was just curious to see what it would do, not fine-tuning it at all. I didn't even, this was before I had gone through and condensed the genres. I just let it like start putting genres in there. And this list goes on, like it's a ridiculous amount of genres, but it looked like there was some kind of just initial, like there was some kind of clustering that it was trying to find. It had this section up here and over here, and there was definitely some different like colored plot points so you could find things, but not really usable. So then I took about actually fine tuning it. And after doing that and trimming down the number of possible genres that it could actually use, I ended up with this, which I thought was pretty interesting. Before I even ran an algorithm to try to like come up with actual clusters, which I did later, but that there was this very clear section that the color for most of these dots turned out to be short films, whereas most of the rest of this was a combination of drama and action. Some of the stuff over here on the side, this is actually the color for adventure. And then a lot of the darker yellow is actually comedy. And it looks like there was a clear, like some kind of thing that differentiated something that was more action heavy versus something that was almost purely drama. But a lot of this is just the same. So then I ran a HDB scan algorithm over it to try to cluster it and calculated a V-score. The V-score goes in a scale of 0 to 1 and tries to determine whether the predicted label in the cluster is identical to the label that it actually had. So the closer to 1 you get, the more accurate it was. And when I just first was tinkering with it, I didn't really get anything terribly useful. And after about a day of tinkering with parameters and some more research, the closest I could get to this, which was still pretty awful, the V-score was just barely 9%. But it did come up with some things that I thought were pretty interesting, that it did kind of notice the same kinds of things that I had noticed, where the center section seemed to largely be the same, but there was stuff on the right-hand side and the left-hand side that seemed to be like certain kinds of genres were clustered in those sides, but not anywhere else. And here I just talked about how I measured that performance. And I thought about things that I could do to improve it. And one of the things could be better labeling, spending a lot more time going through and trying to very precisely pick exactly what genre that plot summary best fit. But over the course of 42,000 data points, that would take literally forever, and I don't have time for that. And then classifying any complex story via one genre is just difficult. Just go look at Netflix, search for look at their different categories, and you'll see the movie in several different categories.
Yeah.
So I figured it was just a hard problem to begin with. But ultimately, I thought that it was interesting that it could kind of see certain distinctions. And I was curious how well it could do to actually like cluster the movies out to the genres, but ultimately came to the conclusion that it is a really difficult problem to try to solve, especially in a limited time frame that we have during the final project for a course.
Yep. So your data is plot summaries, and you're trying to predict a genre class for it, correct?
Yes.
Okay.
I mean, this one I can actually look at the code for. So
And then you, based on that, you cluster them.
Yes.
Also.
This was the after I had fine-tuned it. This was the clustering that it had come up with.
Yeah.
Like just the raw points without running an algorithm to try to define groups on it at all.
Mm-hmm. Okay. So what does in the fine tuning, what does your data look like? You give it a plot summary, and then you give it the label that it belongs to.
Yeah.
The
So this is the data it's fed. It's fed this plot, which is truncated to 512 characters. And then it's also fed, there's just one simple
drama
genre tag. So it'd be like drama, adventure. And like I said, I had to trim a lot of these out, combine some of them because you'd see like romantic comedy, something else comedy, this comedy.
Did
that
you try to do, I guess, a classification where you give it a new genre and then it predicts, oh yeah, this is comedy?
So these results are actually, so when I ran, actually, do I have a screenshot for it? Maybe I have a screenshot. I did run here it is, the screenshot. This was, so I had broken up this data into a training and a testing set, and this is what I gave it with just the test set, like that it had never seen. And I had a similar kind of thing show up where a lot of the and these colors were also like these darker reds happen to be action. Like it's the same kind of basic split where basically you only really see the same 3 or 4. A lot of these greenish colored dots are actually science fiction or romance. But like there was this very clear, something seems to, from the algorithm's perspective, kind of clump action on this particular one. It clumped them in the south, and then more of the drama up in the north of the upper part of the graph. So I kind of had a very similar result, but I didn't have anywhere as many data points, and it didn't seem to. I don't know if there just wasn't a lot of short films in this particular cluster.
Predicted values and then just plotted, basically.
Yes.
But we don't know if they're correct or not.
No idea if they're correct, but it did seem to match the pattern based on the other one where
it matched the pattern.
Where it matched. So it seemed like it was trying to do something. And I ultimately came to the conclusion that the real problem again is just trying to classify a plot summary, especially a plot summary that isn't tried to be condensed into the 512 character limit.
Yep.
And then just trying to condense that all into one singular overreaching label that like would clearly identify it seems almost foolish. Just given how complex stories can be and how many different inspirations and all that they could have. The code for it was actually pretty simple. This was just the part that trained the model, and then I saved that model so that I could save it overnight, and then work with it from there. So this just loaded in the training data and output it, and then this one reloaded it, and then I spent a lot of time. I tried a different clustering method. This one completely broke and did not ever give me anything. So I played with this one, and I adjusted the parameters for this. I don't know. I spent 3 or 4 hours playing with these parameters, trying to find some good results. Notated any any good ones that I found. And the best one again was just this 0.9% or 9% value. It never got, you'd like to see this be something, you know, maybe like 30, 40 or higher. And it just never did get there.
Okay, all right. Yeah, that makes sense. Okay, guys, do you have any questions for Jeremy?
Oh,
No question. All right, great job. Thank you very much.
All right.
All right, do we have one person left? Jason.
yep.
Go ahead, Jason.
Okay. So just to I trained not I trained, but what I noticed what for the homework I used the Wizard of Oz, and I kept increasing the amount of data I gave it by 5,000. So I'm not going to read all of them to you guys, but just to show that the more information that it received, the more it started to make coherent sentences. So at 10,000, oh, and I fed it, there's no place like, because, you know, it's the Wizard of Oz.
Yes.
So came up with, at 10,000, came up with, there's no place like a sorcerer. I will not be a wizard, said the prince. What do you are better than I'm a wonderful wizard of our wizard, and that you not? Asked the wizard. No, replied the little man. If you will explain to be seen, remarked the star piglet in this country. So we you to stop my breath. So, you know, it's a little kind of rambling and incoherent.
Yeah.
I won't read the whole thing for 10,000, but then at 30,000 here, oops, 30,000 comes up with, there's no place like a figure of a cat, said Jim, and she went down anyhow, whether she climbed or crept. Dear me, how careless Eureka is, exclaimed the girl, much distressed. The gurgles will get her, sure. They're not gurgles, little maid. They'll get Eureka whatever they don't, remarked the voice of the kitten, and Eureka herself crawled over the platform and climbed down quietly upon the She is Eureka. So yeah, that one's
yeah, that one's it's doing like reference resolution there. So
yeah.
Pronouns are referring back to the things. That's very interesting.
Yes, and then you can really tell at 50,000 it's pretty good. So even though, okay, so at 50,000 it came up with there's no place like a trial. I'm trying to be free, cried the Tin Woodman.
Really?
Or you may be sorry for the piglet that belonged to the princess wore an emerald collar, said Eureka loudly enough for all to hear. So it did, exclaimed Ozma. This cannot be the one the wizard gave. Of course not. He had 9 of them altogether, declared Eureka, and I must say it was very stingy of him not to let me eat just a few. But now that I will, so you know, it does get better the more you give
that's
it.
interesting.
I won't.
So describe this experiment of going from 0 to 50,000.
Yeah, and I still I ran out of time. I wanted to drill down a little bit more and give it the whole like the whole book, but I was short about 10,000. So I don't know exactly what I had to change to get the whole, probably the sentence size. But yeah, so I noticed that it was kind of nonsensical at first. And our example we did in class, we only did like 1,000. So I just kept increasing the size of the script that I gave it.
So is it the size of the book that you gave it?
Well, the size of the book and how much of the book that I gave it.
Right. So we would take a book and then we would sample a few passages, but you kept giving it more and more.
Exactly. Until I I could, like I said, time constraints, I wasn't able to figure out what I needed to tweak to get the whole book in there,
Yeah,
but I came close.
right. No, that's good.
Uh,
It's very interesting.
Yeah, it's pretty interesting. Like if you, I don't really think there's time to read through the whole, you know, the whole paraphrase of all of it, but
Mhm.
it did pretty decent.
Yeah, no, it's true.
So I'll get to the slideshow here. Okay. This slide. So I'm doing transformers autonomous source code classification.
Okay, so you're done with your GPT-2 presentation?
Yeah, I
Okay.
kind of
Yeah, that
focus more on
Okay. Okay.
the,
So you said source code classification, not source code translation?
correct. I almost got to translation.
Mhm.
And I did do a couple, but I wasn't really getting good results just yet. So the agenda for this is a project setup, the data set, some masked language modeling, zero shot classification,
Yep.
multi-class classification, then unsupervised learning to like do a check on my classifications and some auto completion. And the project setups, research and data set development, transformers designed for NLPL tasks, which is natural language programming language tasks. I found 2 pre-trained ones. CodeBERT, which I used, was trained on, I think this might be wrong, it might be 6 programming languages actually, and mainly made for replace token detection and masked language modeling, but also some natural language code search and code documentation generation. And the TreeBERT, I didn't use it at all or even get to that because it's a whole nother ball of wax, kind of more focused on using the abstract syntax tree of a programming language.
Yep.
And doing tree mask language models and node order predictions. So these are the programming languages that CodeBERT was trained on and the size of the data set. So 1, 2, 3, 4, 5, 6. Yeah, it was only 6. I accidentally counted this one, but that's just all. So, and I kind of focused on my project on Java, PHP, and Python.
Mhm.
And so the discretization and comparison of the training data set that I made, my collection methodology. My optimal approach was I wanted to make a spider and have it crawl through like W3 schools and some other sites, but that was basically a whole project itself.
Yeah.
So I gave up so that I could get this part done. And
Right.
the approach I did take was I just collected some samples by hand from W3 schools and a couple other sites. And then for my data set creation, I processed a parallel list that I had made. And during my zero-shot.py program, I classified it into a CSV file called programming languages.
So basically what
And-
you're trying to say is this code, is it Python, PHP, or JavaScript?
Yeah, all my examples that I used for my project are these 3 languages.
But that's what I mean is what the transformer does is it classifies it into one of these 3 labels.
Yes.
Okay.
So well, like I said, I did a few different things. I'll get to all of them. You'll see, hopefully. So I made bins and I made sure that, you know, like we're supposed to do, like the iris data set, that they're all, it's not an uneven data set. So I have 12 examples of each. Then my code, the sample size comparison and like the number of characters of the purple is Java, the magenta's PHP, and Python's the blue. So, and when I first started compiling, I was just picking some random things that I thought of in my head. But about fourth of the way through, I actually started matching the code the code snips. So like, for instance, this would be like a linked list in Java, and then the linked list in PHP, and a linked list in Python, and then like a constructor in Java, and a constructor in PHP, and a constructor in Python. So
Yeah.
most of my data set is matched up like that, but not all. And then for the masked language modeling, I used CodeBERT, that is, and an example sequence that I would feed it. So, you know, I use the mask. We got to use the mask just like we did for our examples in class. And for this one, pipeline would be the answer, right? This would be pipeline right here that's masked.
Yeah.
And this is a sample output that I had it fill into XLSX files. And so this is the score that's generated by the model, the token string that it comes up with. So this is like how sure it is that it might have the correct answer. And then what I masked, and then I tested, there's code that tests to see if the string matches. And then if the string didn't match, I would check for a match in a substring. So if whatever answer it came up with, if the real answer was inside as a substring.
Mhm.
And so the performance was partially peaceful with signs of Miss Pac-Man. So because it's like, anyways, that's just my humor. So my test cases, it wasn't like I barely had any PHP in this one. It was mainly Python and Java. And then it was 80% of the time it matched the string. So it came up with the correct answer 80% of the time pretty much. And it didn't really do any substring matches. So if there was a substring match, it would already, you know, it matched the string first, so it didn't matter. And in zero shot classification, I tested CodeBERT against BERT large. And for an example, PHP sequence that I fed it, looks like this. And output for that, I didn't put the sequence in here because I just showed it to you in the last slide, and it makes the table look horrible. So this one is an example of it getting it incorrect. It guessed that it predicted that it was Python, and it was, you know, so at least it wasn't like 90% certain it was Python. It was kind of low still.
Yeah.
And even though I didn't do any Ruby examples, I left it in as a label to see if it would, you know, mess up the algorithm at all. And so I had 36 samples, and what I did was I just looped 33 times, and it really didn't change the outcomes very much. That's why that's why the predictions are kind of high, the number of them anyways. And CodeBERT, it didn't do all that great compared to BERT large, which when I started, I thought I was in trouble because I was only using CodeBERT and it wasn't doing very well. I didn't have very many samples, but BERT large did well. So my transformer model comparison, this is like the bar graph of the outcome. So BERT large, these are correct versus the total number. BERT large did pretty good. So I decided to fine tune on BERT instead of using the CodeBERT. And I used BERT based uncase. And so I basically created the data frame. Programming language.csv file is what I used to train on. And I mapped the labels. I got the tokenizer in the model, tokenized the data, and then I trained. I started with a smaller data set and less epochs. And then once I got the fairly evened out data set of 36 samples, 12 of each language, I just increased the epochs, and it did good enough with that small of a data set for fine tuning. And I think I could have I think it optimized around 1200 epochs, as we might get to later in the Wanda B output So I trained with metrics. I saved the model. So I didn't test yet, but I was just making the model. And then I make predictions from the multi-class from model Py file. And we'll go here later. I tried doing this. It won't do both things at once, go through the slides and go to the website at the same time. So I'll come back to that.
Mhm.
So on my held out examples, it was 100%. It guessed correctly or predicted correctly every time. And my held out examples weren't completely, but then I don't think the held out examples need to be as just when you train that you really want the, even bins, but they're pretty close to even.
How many did you have of each?
Ooh, I don't think I can go back. I had roughly, let me see. I
Of
think
those
I had,
test samples.
yeah, it was somewhere around like 6 each, I think. When this is over, we can look. I'll tell you
Yeah.
for sure.
Mhm.
So then the unsupervised learning, I just wanted to see if there was correlation. If my classification model might be bogus. I used a paraphrase distill Roberta based V1 for the unsupervised learning and the k-means clustering.
Mhm.
I had 3 centroids, of course, because I had 3 languages and they're all kind of in their own zone. There's 2 stragglers over here of class 1, but they kind of stay in the grid away from these other ones of the class 0. It kind of, since they weren't labeled, it was unsupervised and they're clustered really good. I feel like 100% on the model on the classification is justified. I don't feel like it was overtraining or anything, because I mean, if we look at those 3 languages ourselves, there's like PHP and Java and Python have their kind of own identifying characteristics. And
Yes.
some of the examples that I did use early on that I masked were syntax examples as well, not just like a word. I would like mask like comment marks or semicolon, and it would pick up on most of those, but not all. I don't think it got the semicolon, but it got the comments. So I think that the models were done well. Then you auto-complete me. So I used so this is what happens when you make these when you're up late at night.
This
So I
is
used
interesting here, what you're doing.
yeah.
Did it work?
GPT-2, sort of. It is interesting enough.
Let's take a look at this.
Yeah, so, and I didn't do too much that I put in here, but the data set that I found, this was its training and the validation and the test. So that's the size of those. Then, for instance, the first prompt I gave it was a linked list, basically. And then down here, you would expect something about the like initializing the head of the node. So what it came up with, this would be the next line where you would want it, and it did. It came up with self.node, but then it kind of, which should be none, so it was almost right on the next line, and then it just came up with some interesting but kind of random. I mean, it generated this parent node to list, so from the examples,
You don't know, that may be some seriously advanced coding that you just don't understand.
This is true. It could, this part could be ahead of me, but
Yeah. That's
so
interesting. I like this idea.
Yeah, it's, it's not completely bogus. There's something to it. It comes close.
Yeah.
It almost got the next line that I would expect, like right on the money. So then the prompt 2 just gave it this, definition of factorial n, and it made a recursion, even though it kind of didn't do it exactly right. And then it actually came up with a factorial. This is kind of how you would do it.
Mhm.
So
That's
I
really
thought that was, well, not really. It would be,
How much data did you give it of Python?
I'll show you that in a second.
Because
I-
for
it's
this
not-
autocomplete, you must have fine-tuned it, right? So you gave it
that I actually
how many
I
lines?
didn't, but I will show you what I used when the
How did it know Python? I mean, because it's obviously.
well, I'll
writing
show you.
Python.
I will show you that after the slides, which is I'm almost done with the slides.
Yeah.
I can't like get to that information while I'm doing the slideshow. So then my project timeline, I don't really need to go over this with you, but I started with masking.
I get a feeling you guys are double dipping, and this is a project for another class too, right?
Oh no, this is
No?
my only class
Oh,
I
okay.
have where I do this kind of information. I'm definitely not double dipping on this.
No, I'm just kidding. I was joking.
Okay, well,
What is this timeline? Yeah, all right. Go ahead.
so well, this is kind of basically how my whole project came together.
Mhm.
Well, I just started, like I found CodeBert and I realized I could do masking with it. And so I started, I grabbed some example codes and I tried masking them. And then I formulated, while I was doing that, I kind of formulated how to make my data set for what I wanted to do later. And it was all just a list. It's in a list form in the zeroshot.py program. But then while I'm doing my zero shots, I generate my CSV file from the list so that I can train my multi-class model and fine tune it with that data set that I accumulated for the zero shot examples.
Mhm.
And then, so I made the model, and then on the held back examples, I ran the classifier on them, tested it, and it got 100%. And then I did the clustering, and then I had a little bit of extra time, so I did the autocomplete. And I started to try and do the translation from one language to the next, but it wasn't working out very well, and I kind of ran out of time. So couldn't have done it without my team. My tech support really came through for me. More humor, and then thanks.
All right. Good.
Okay.
Good.
So so I can show you what I found for okay, so you were asking me about the autocomplete.
Yeah. Just how much data did you give it?
I found this
Okay.
here. And
Mhm.
well, I think, hold on, actually, didn't I? Oh, so this was the data set, the information.
Yeah.
So
I was just curious, like how many lines of Python code does it take for it to at least be able to write out Python syntax,
yeah, so
even if the
it's saying
logic is
right,
not correct?
it's saying here that the training data set was what is that? Yeah, 5,215,000 rows.
Okay.
So pretty decent sized.
Mhm.
And I found some other data set, but I could not figure out how to run the run.py file. It was this mix of PHP and Python.
Yeah.
And I didn't know what I didn't know how to run it to get the data set, but I did decent with my own little data set. But so this was what I used, this shipping 624 source code. And then they actually had a Java or a CPP as well.
Yeah, I see.
But I just stuck with Python.
Oh, that's good.
So then the GPT-2 tokenizer and head model, and same things as shipping 624. So then you give it a prompt or a sequence, you know, it's basically like the same kind of stuff I trained on, and then it will spit out a decoded auto-generated text. So, and did you have questions about any of the other?
No, that's no, clear actually. That's pretty good. I like the last one, the autocomplete of Python. Thought that
Yeah,
was a
so
very nice idea.
thanks. So for example, like here's, it started as a list and it's all that right there. And then I made a CSV file out of the list that I carried on to do the training in my multi-class model and everything. So,
Okay. All right. Great. Great job. Guys, do you have
Thanks.
any questions for Jason?
No, I thought the autocomplete was pretty interesting.
yeah, I definitely have, I'm interested enough in some of this where I'll probably continue to look into it.
Yeah. You guys know the rule, right? I own 10% of any companies that you create. All right, good. All right. So, well, I think Jason was the last presenter for today. So great job. I really enjoyed the project. Learned a lot. Actually. So do you guys have any additional questions or comments about the course?
I have one additional question. You said that next week we're doing our final, and you're just gonna open the final at the correct time?
Yes, at the correct time. So you can look it up on BNW final exam schedule. And it'll probably be, I think it's like 2:45, I think.
Okay, sounds good. And then you also open a Dropbox for the assignments?
That's right. I will create I think there's already a Dropbox for the GPT-2 homework.
Yes.
And
There is.
yeah, and then I'll create a Dropbox for the project. I usually have a folder at the very top called project and ABET surveys. I don't even think I need to do ABET surveys for this, but I'll post that anyway. So yeah,
Right,
so
that's
your
it.
class, yeah, your class is Monday and Wednesday, so 2:45 to 4:45 Monday. So that's all you have left. So I'll create that link soon and then submit your materials. And oh yeah, so submit a report, but also zip all your code, okay? If you don't mind. Okay.
Sounds good.
Yeah, so
Yeah.
zip up all your code files, etc., and load it up and the report. So I want to take a look at some of your code. All right. Yeah, so I'll stay for a few minutes if you have questions. Otherwise, we are done for today, and I'll see you guys for the exam. It'll be online, so I'll be in my office, but you can just take it at home.
Cool.
All right.
Thanks.
Yep, that's it.
Thanks.
Yep. See you.